So I'm going to run you through the process of moving from 3D CAD to a program called Cut2D that lets you set up machining parameters for the CNC router. And then in a separate QR code, you'll be able to see how we set up the post processor and how we export the job through another program called WinPCNC. Okay, it sounds a bit long-winded, but I'm going to start with a 3D CAD drawing that you can see on the screen. So this is just the thing I've made up, okay? It's a little 8, but I've done something here that is going to allow me to show you a couple of different functions of setting up toolpaths. So the 8 has got a hole that goes through on one part of it and a hole that goes part of the way through on the other. So this is what we call a through hole. It's what we call a blind hole. Blind hole doesn't go all the way through. Okay, so first thing I've got to do is I've got to export that shape, right? So what I'm going to actually export is a 2D part of the drawing. It's not the same as exporting to the 3D printer, where you'd be looking to go right-click on here, export, and export the whole thing as an STL file. I'm not going to be doing that, right? It's not 3D. I'm exporting to 2D, okay? So what I'm going to do, I'm going to go to Sketch 1, which is my 8 shape. You can see it's pre-highlighted there. And I'm going to right-click on it, and I'm going to export as DXF or DWG. So it's the DXF I'm after. Always good to give it a name that you'll remember. I'm just going to call it 8 piece. And it's a DXF file. Now, the release 11 to 12 may have an impact on the way this thing is exported. I'm going to leave it as a release 11 to 12. That's just a kind of AutoCAD file format that the other machine's going to read. So leave it as release 11 to 12 and then click export. Okay, now you'll see that piece has been exported and is in my downloads folder. So with that done, my next job is going to be to open a program called Cut2D. So on the machine that you can see just below or to the right of the CNC router that's below this display, you'll see the computer and it's got Cut2D installed on it. Okay, so I need to go to Create New File. Now, the size of the material that I've got in here is the first thing you need to consider. So my job that I've got is 100 by about 150. So I'm going to set the size of it up in a second. I'm just going to OK that from. We'll come back to that page in a second. Next thing I'm going to do, I go File, Import. Now, if I go to my Downloads folder, I should be able to find downloads. 1 second. Downloads, there we are. Okay, so there's my piece that I've just created. And what I'm going to do is I'm going to lasso that piece there, click on it once, and then drag it onto my page like this. Now, so there's my shape. And next thing I need to do, right, I'm going to set the material size up. So the page that I just closed down before, edit, and then go down to material size. Now I can shrink the size of the board that I've got. So I'm going to go for width first of all, and I'm going to bring my width down to about 150 millimeters. Now we don't want to waste material, but at the same time we need to have enough to allow for maybe a little bit of misalignment of the job. And so I'm going to change that down a little bit. Material size, I'm going to bring that down from 150 to 120. And that's looking better. The height of the material, though, I'm going to change. I'm going to bring that down from 250 to about 200. Okay, so there's my material, and my vector is centered roughly in the material. Oh, hey, by the way, there is a way to really accurately center it. If you go to this button down here, Align Vectors, it'll actually, if you select the vector first, it'll actually align those vectors to the middle of the material like that for you. Okay, next thing, back into material size. And in material size, I've got a few more things I need to check, all right? The XY origin position needs to be set to bottom left-hand side. Don't use origin offset. Start with it on 0, 0. And the thickness of the material. So I'm going to make this out of some 18 millimeter material, which is exactly the same as the material I had on my CAD program. And I'm checking that my units are metric mode, so I'm in millimeters. Click OK. That's it for material setup. Okay, next job then. I need to try and start creating some what we call toolpaths. So my first thing is I need to create a toolpath that's going to cut the outside of this piece out. Now, if you remember, go back to my 3D CAD drawing a second, right? The larger of the two circles is the through hole, okay? So that one's going to go all the way through. This one's not going to go all the way through. Okay, so this cutter path is the one we're going to set up first. First thing I'm going to do, I'm going to go to the button that says Join Open Vectors. And join open vectors has got a tolerance by here, which is set to 1 millimeter. Now, if that's blanked out, it means there are no open vectors. But if you see there's a number in here for open vectors, you have to find a value that will close those vectors off. You cannot have an open vector. Okay, so you need to have a closed shape. Next job, with that selected, you click on the toolpaths button and you go to the bottom here to create a profile toolpath. Right, so profile toolpath now, look, has been picked up using that vector, and that green dot is your start position the router is going to go to. First of all, drive itself up to that green dot and then start cutting in a direction. And we'll go on to the direction in a second, which is to do with this climb and conventional. Okay, so next thing, what's the final depth of the cut? Well, I want to cut all the way through the material, so I'm going to get at 18 millimeters. Next thing then, tool. Okay, so the tool I'm going to use is, I'm going to select it by here a minute. I've got an end mill, 3 millimeters diameter. Now, what's the difference with an end mill? Okay, so an end mill, a milling cutter, isn't the same as a drill bit. Okay, a drill bit has got a sharpened end and can only ever cut up and down. But a milling cutter has got a flat end, or sometimes a rounded end, but it can also cut left to right. So it can get up and down and left to right. So the diameter of my milling cutter there is 3 millimeters. Next thing, cutting parameters. Okay, cutting parameters. If I try to get that cutter to go 18 millimeters into the material and cut it all in one thickness, I'd probably break the cutter or burn it out or cause massive amounts of damage to the machine. So I need to do it in steps. So my next step is to decide how deep those steps will be. So my pass depth I've got set with my cutter is 2 millimeters. Now it's best to be conservative. Okay, go for a smaller size and then decide whether you can increase it on the next cut. Step over is the distance that the cutter moves across. So that's either in the X or the Y axis before it does another run. So 1.2 millimeters goes almost the radius of the cutter before it does its next cut. I could push that right up to almost 2 millimeters and I would still have no problems. That's 40% of the diameter there. You got it set up. Spindle speed and feed rate. We can change the feed rate. So the feed rate is millimeters per second, how fast the cutter is going to travel through the material. Spindle speed is the rotational RPM of the router. Now we can control it a little bit, but not massively. Okay, we can't control it through the software here. Okay, so next thing. So if I go apply on that one, so that's my cutter chosen. Go back into my toolpaths a minute. So that's my tool setup. Next thing is machine vectors. Now this is where I'm doing my things called offsets. So the offset on a cutter is deciding whether the router cutter is going to cut outside the line, inside the line, or on the line. So if you can look at this picture again, once I select those different options, outside the cutter will make sure that you end up with this box being the same size that you drew it. Inside is going to make the outside of the box the same size as it was, and on is going to reduce the box by the radius of the cutting tool. So it reduce it by 1.5 millimeters, on all the sides. So be careful with that. Okay, I need to cut on the outside of this one because I want the 8 to stay the same size. Next thing, climb versus conventional cutting. Right, okay, so conventional cutting, the router would run this way round and travel anti-clockwise. The router itself rotates clockwise. So a conventional cut would be what's called upcutting, and it would be removing chips running clockwise direction and traveling in the same direction as it is cutting. But my climb cut is going to move in the opposite direction. So it's going to rotate clockwise and it's going to rotate cutting in this way. Now it makes for a quieter cut and a slightly better surface finish with the router cutter we're using. Ramp plunge moves we don't need to. And then we have add tabs. Okay, this is a good important one to go over. If you click on add tabs, you can actually increase the strength of your job as it's set on the tool table by including some little tabs that will remain uncut after the cutter path has finished doing its job. So that is now my cutting path setup, my first cutting path setup. So if I click calculate on that, what I'll get now is a little 3D view. Now you can see here these blue lines are 2mm steps. So 2, 4, 6, 8, 10, 12. That's going to end up going 18mm down in 2mm steps. And you can also see these tabs that have been left on the edge of the material. So if you go to toolpaths now, oh, and the red line, look, is showing you the path the router is going to take from its origin over to where it's going to start doing the cutting job. If I run to my toolpath job here and I go preview toolpath, it will actually give us a visual of how that bit is going to look once it's cut out. So it really does cut down the risk of having errors with your machining setup. Right, now let's set up a different toolpath. So that toolpath stays, that's just called toolpath 1 or profile 1. And I'm going to create another toolpath. So go in here and click on the inside line. Now just check a second that there are no open vectors. So there's no open vectors there, so that's fine. Go over to toolpath and click on profile toolpath again. And the only difference will be here, we're going to leave the end mill as it is. We have to click on inside line because this one, we want the circle to stay the same size, but remove the inside part. I am going to add tabs. It's always good to add tabs in there to make sure that we're not going to get any movement of the job. Don't add too many. I think 2 would hold that just there fine. And close that a second. And then I'm going to go down to calculate. And you can see then it set that toolpath up for me as well. Right, let's just go back into toolpaths and I'm going to reset the preview. I'm going to go preview all toolpaths this time. So you can see now it does profile 1 and then it does profile 2. So you can see I've cut the middle of the 8 out. Okay, so that's my through hole. My next one will be to cut the blind hole. So the blind hole, look, is going to be a different kind of setup. So I've got profile 1, profile 2. Go back into untitled. Select the one that we don't want to go all the way through. Back into toolpaths. Don't go to profile toolpath this time. Go across one to where we see pocket toolpath. And the depth of your pocket toolpath. Okay, I've got mine set up so the bottom of it is 6mm thick. The total thickness is 18. So 18 minus 6 is 12. So I want to go down 12mm. Again, I've got my Kleiman conventional cut set up. Don't need any tabs for this because that material will remain stuck in place. So if I go calculate, you can now see if I go to reset preview and preview all toolpaths that my 8 figure is going to be cut through and then have a pocket taken from it. Next job then, select all of your profiles and go down to the button that says save toolpath. Okay, and as long as you've used the same cutting tool for every toolpath, you shouldn't have an error message here. You may have an error message if one of them is using a different tool. We don't have something called Auto Tool Changer on this machine, which would automatically change to different kind of cutters. So all the different toolpaths have to use the same cutter. And over by here, you want to make sure you insert one called WinPCNC. So find WinPCNC. Okay, I think you'll find it on the machine that's connected there, but I haven't got it installed on this computer. And make sure that you're in the right format for post-processing. Save the toolpath and you're good to go. Just get somebody else to check through that to make sure you haven't set the cut depth too deep and using the right tools and things like that. But I hope that video's been useful. So well done. Have a scan around the display and see if you can see any more QR codes. There'll be guides to setting up different parts of the machine. Okay, well done.